Good morning, dear student. Today I am continuing the previous lecture. How to find the PI, this means particular integral of the differential equation. Because I am simply find the CF of the differential equation. Now next is the PI. Because the solution of the any differential equation, if it is by rule PI. Now I am consider the next rule of the finding the PI. Please you can note down. The rule of find the PI, this means particular integral. You can note down if 1 upon fd x to the power n cos ax plus I sin ax, then 1 upon fd x to the power n cos ax is equal to real part of e to the power ix aix 1 upon f d plus ai x to the power n. Now second is 1 upon fd x to the power n sin ax is imaginary part of e to the power iax 1 upon f d plus ai x to the power n. This is a very important condition to find the PI. Now you can first note down example number first. Find the solution of differential equation if d2y of dx2 minus y is equal to x sin 3x plus cos x. This is your numerical. Now first of all you can write solution of the differential equation. We have d2 minus 1 y is equal to, you can write x sin 3x plus cos x. Now first of all you can find the AE, this means auxiliary equation of the differential equation first. This is equation number first. First of all you can write AE is equal to m square minus 1 is equal to 0. It means m is equal to plus minus 1. It means two roots of this equation. Now second is finding the CF. This means coefficient factor. Now you can write CF is equal to C1 e to the power x plus C2 e to the power minus x. This is your CF. Now second is finding the PI. This means particular integral. First of all you can write the PI is equal to 1 upon d square minus 1 x sin 3x plus cos x. Now you can write 1 upon d square minus 1 x sin 3x plus 1 upon d square minus 1 cos x. Now next is you can write 1 upon d square minus 1 x sin 3x plus, now by applying the PI rule you can write 1 upon minus 1 square minus 1 cos x. Now you can write 1 upon d square minus 1 x sin 3x minus 1 upon 2 cos x. Now this function you can apply the this pi rule. 1 upon f d x to the power n sin ax is equal to imaginary part of the e to the power I ax 1 upon d a plus I. Now you can write imaginary part of e to the power 3ix 1 upon, you can write d plus 3I to the power 2 minus 1 x to the power x minus 1 upon 2 cos x. Now you can simplify this function. You can write imaginary part of e to the power 3ix. Now you can simplify this value. You can write a plus b to the power 2. You can write b square minus, sorry, plus 9i square minus 6bi minus 1 x minus 1 upon 2 cos x. Now you can write imaginary part of e to the power 3ix 1 upon, you can write b square minus 6bi. Now you can write minus, this means minus 10. Since I square is equal to minus 1, x to the x minus 1 upon 2 cos x. Now you can note down this numerical. This is very important for your examination. First of all, you can note down. I am continue to this step. You can write, you can note down this step. Now you can write imaginary part of e to the power 3ix 1 upon, you can common to this function minus 10. Now you can write minus 10 1 plus 6di minus b square by 10. Now x minus 1 upon 2 cos x. Now you continue to this step. Imaginary part of e to the power 3ix upon minus 10. You can write this 1 plus 6di minus b square upon 10 to the whole power minus 1. This means inverse x minus 1 by 2 cos x. Now again you can write imaginary part of e to the power 3ix upon minus 10. Now you can open this function. You can write a x plus a to the power a plus x to the power n. Now you can write first 1 minus 6di minus b square upon 10 plus 6di minus b square upon 10 to the power 2 minus is next. Now x minus 1 by 2 cos x. All the function will be cancelled, all next term will be cancelled because only the power of x is equal to 1. Now you can write imaginary part of e to the power 3ix upon minus 10. Now you can differentiate of this value 1 minus 6i upon 10. Now next is cancel because only the x n to the power 1 is equal to 1. Only one time of differentiate to x. Minus 1 by 2, sorry, this is x. 1 by 2 cos x. Now you can write imaginary part of 1 upon minus 10 cos 3x, the value of e to the power ix plus I sin 3x x minus 3i upon 5 minus 1 by 2 cos x. Now you can write imaginary part of 1 upon minus 10. You can multiply to this function. You can write x cos 3x minus 3I upon 5 cos 3x. Now again multiply of I sin 3x. Now you can write plus I x sin 3x. Now you can multiply this minus 3I square sin 3x upon 5 minus 1 by 2 cos x. Now you can simplify this function. You can write imaginary part of 1 upon minus 10 bracket x cos 3x minus I 3 by 5 cos 3x plus I x sin 3x minus plus, because I square is equal to minus 1, 3 by 5 sin 3x minus 1 by 2 cos x. Cos x. Now you can write this 1 upon minus 10, subtract all the I. Now you can write x cos 3x. Now again is plus 3 by 5 sin 3x minus 1 by 2 cos x. This is your PI. This is your PI. Now this is your PI. PI is equal to minus 1 by 10 x cos 3x plus 3 by 5 sin 3x minus 5 cos x. Now again the solution of the differential equation. Solution of the equation, you can write y is equal to CF plus PI. CF plus PI. You can write the CF plus pi, put the value of CF, and this is the value of PI. This is your solution of the differential equation. Please, you can note down. If any problem, please you comments to my video. Continue to this lecture. You can write rule of find the particular integral. This means PI of any function phi x. This is the next rule of the finding the PI. You can note down, if 1 upon d minus a phi x is a PI. Now you can write 1 upon e to the power ax integral e to the power minus ax into phi x dx. This is your function and this is your PI. Now the next example of this function, you can note down example number first. Find the solution of differential equation if, you can note down the numerical, d2y of dx2 plus a square y is equal to sec ax. This is your differential equation. Now the solution of this problem, first you can write, we have d2 plus a square y is equal to sec ax. First of all, you can find the AE. First you can find the auxiliary equation. This means AE. Now you can write m square plus a square is equal to 0, or you can write m square minus ai square is equal to 0, or you can simply write m is equal to plus minus ai. This is your cm, roots of the differential equation. It means ae. Now you can write the cf of this equation. CF of this equation, you can write C1 cos AX plus C2 sin AX. This is your CF. This is your CF of the equation first. CF of the equation first. Now again find the PI, particular integral. This means PI. You can write PI is equal to 1 upon B square plus A square sec ax, sec ax. Now you can write 1 upon d square minus a square I square sec ax, or you can simply write 1 upon d plus ai into d minus ai sec ax. Now you can write 1 upon 2ai 1 upon d minus ai plus, sorry, minus 1 upon d plus ai sec ax. Now you continue to this step. You can write 1 upon 2ai bracket 1 upon d minus ai sec ax minus 1 upon d plus ai sec ax. First of all, I am solving this function. Case number first, I am solving 1 upon d minus ai sec ax, sec ax. Now you can write you can continue this step. You can write 1 upon d minus ai sec ax. By applying the pi rule of this function or any function, you can write e to the power minus ai x integral e to the power ai x into sec ax dx. Now you can write e to the power minus aix integral, put the value of e to the power iax, you can write cos ax plus I sin ax. Now you can write the sec, this means 1 upon cos ax into dx. Now you can simplify this function e to the power iax integral. You can multiply this. Now you can write 1 plus I tan ax into dx. Now you can integrate this function. You can write e to the power minus iax bracket x plus I upon a log, this is a minus log sec ax, or you can simply write log cos ax. Now you can note down this numerical. If you have any problem to finding the pi or a cf, please you comments to my video. I am also again discuss how can find the cf and pi. Now you can, first of all, you can note down this numerical. Now I am continue to this step. You can write e to the power minus iax bracket x plus I upon a log, if minus is transferred to this function, now you can write log sec ax, log sec ax. Now case number first, this is case number first. This is the value of 1 upon d minus a d minus ai sec ax is equal to e to the power minus iax bracket x plus I upon a log sec ax. Now similarly, case number second, find the value of 1 upon d plus ai sec ax is equal to, similarly case number first, we can write 1 upon d plus ai sec ax is equal to e to the power aix bracket x minus I upon a log sec ax, log sec ax. Now pi is equal to 1 upon 2ai bracket e to the power minus iax bracket x plus I upon a log sec ax plus e to the power iax bracket x minus I upon a log sec ax. Now you can write 1 upon 2ai e to the power iax plus e to the power minus iax, x is common, minus I upon a e to the power iax minus e to the power minus iax into log sec ax. Now you can put the value of e to the power iax plus e to the power minus iax. Now e to the power iax minus e to the power iax. Now first of all you can note down this numerical. You continue to this step. You can write this. Now next step is 1 upon 2ai e to the power iax plus e to the power minus iax into x minus I upon 2a square I e to the power iax minus e to the power iax bracket close log sec ax. Now this is a function of sin x, this is a function of cos x. Now you can write 1 x by a sin ax plus this is a function of 1 upon a square cos ax into log sec ax. This is your pi. Now the solution of the differential equation, you can write solution of the differential equation. First, y is equal to cf plus pi. First you can put the value of cf. You can write c1 cos ax plus c2 sin ax. Now the second value of pi, this means plus x by a sin ax plus 1 upon a square cos ax into log sec ax. This is your final answer. This is your final answer. If any function phi x, how to find the pi of this function? Now this is a most important numerical, and these are many important for your examination.